Hello, this is just an introduction to using the Ender Pro 3D printer. It's intended as part of the training for UVU Physics faculty and students who want to use the printer independently. So this is the first step. Watch this video, and then you'll be ready for a short in-person training to make sure that you're ready to use the printer independently. You can also just ask me for help, and I will do it with you, but if you're going to be printing more frequently, I'd rather that you be able to do it independently. So the first thing to note is that this printer, just to let you know a little bit how this printer works, this is what's known as a fused deposition modeling, or FDM printer. So basically, you've got this hot end that can move around, and basically the hot end, it's just this nozzle that gets really hot, and you stick plastic in it and it runs through, and it just kind of puts stripes of plastic down, and you build things up with that. That's what fused deposition modeling is. We also have a stereolithography, or SLA printer, which is part of my research lab. If you need to use that, talk to me. It's a little bit harder to use, and so I will do it with you, as opposed to the Ender 3 printer, which once you're trained, you feel free to use it on your own. The SLA, I'll be involved. So just to compare them, so FDM printing, the materials are less expensive, more expensive for SLA. It's less messy. SLA involves toxic resins and vapors. The printer's in a fume hood. FDM, once it's printed, you're done, whereas with SLA, after you've printed it, you've got to wash it and cure it. There's less printer maintenance compared to SLA. You're less likely to break the printer using the FDM printer than you are at the SLA, and SLA is a lot more work to fix, too. And there's more maintenance on the SLA. The parts you make on an FDM printer tend to be fairly rigid, but with a little bit of bend, whereas SLA parts are more rigid. If you're going to tighten a screw in it, it's more likely to crack than something that you print with FDM. The resolution of our FDM printer, it's kind of, it depends on how you define it, resolution and which dimension, but let's say kind of 0.2 millimeters-ish. Whereas the SLA printer is more indicative. It's, almost an order of magnitude better. So if you need really high resolution parts, SLA is more useful. Also, FDM parts are very porous. They don't hold water or air, whereas SLA parts are much tighter, and you can get them to hold water and maybe even, not high vacuum type, but kind of, low vacuum useful. All right, so because FDM printing is so much easier to do, there's just a lot of things you can do with it. For example, people have made like giant printers, like this Stargate printer. They even do printing with concrete. You can build a house, 3D print a house, for goodness sakes. And you can 3D print with chocolate. So there's all kinds of things you can do. Whereas with SLA printing, the materials are a little more particular. Okay, so if you're going to print something on our Ender printer, here are the steps you need to go through. First, you need to figure out what it is you want to print. Then you need to create an STL file. That's the 3D file that has the shape that you want to print. You want to make sure that the shape in that STL file is actually printable, and we'll talk more about that later. Then you need to choose a material. What kind of plastic do you want to use to print this? Then you will slice the file. So you use something called a slicer that takes the 3D file and then actually generates the G code, the codes that instruct the printer how to move and how to turn on heaters and such. Then you will put that G code on the micro SD card that goes into the printer. You'll prepare the printer and then print. And when it's done, you'll remove your part, you'll clean up and turn the printer off, and let me know if there are any problems. Okay, so step one. What can you print with a 3D printer? You can do all kinds of things. I printed up some optics kits back when we had to do Physics 4210 advanced optics lab stuff during the pandemic when people couldn't come into the lab. So, I had to come up with a bunch of optics mounts for a laser and such. I've printed photogate mounts for Physics 2215. This right here are some supports I designed and printed to actually hold the filament when you 3D print. I mean, you could just do all kinds of stuff. I've made parts to hold lenses of odd shapes, to mount cameras, to mount power strips to our unistrut cages around our optics tables, to hold light strips up on our table, to mount lasers, to make a box to hold the electronics that runs our IPSI imaging setup. We've 3D printed motorized systems for optics mounts and the thing to hold the motor drivers down to the optics table. Here are some things I printed for an outreach where here's a little projection device and a lens to project an image on a card. If you've ever seen a laser microscope before, I 3D printed these little parts that has a little red laser module and a dropper that you can use to project to make a microscope, a laser microscope. And I found a cool three-dimensional design of a dragon's head. I added the UVU logo and carved out the middle in my file so that I could 3D print parts to make dragon laser pointers for our outreach group. So it's just all kinds of things you can do. So then, once you know what you want, you need to get an STL file of it. An STL file is a file that describes a three-dimensional object. It may be that someone's already designed what you want. You can ask me about it. I've designed lots of parts for lots of things. And there are places online where you can go and find where people have uploaded 3D files that are free for you to use. Thingiverse used to be the big one, but they've been having problems, so people have now been moving over to PrussiaPrinters.org. Prusa makes printers, but they also host the site where people can upload all kinds of STL files you can use on any printer. And Yegi has a search engine that searches across a bunch of different 3D sites. A lot of the things it finds will be not free, but you have to pay for them, whereas all the stuff on these other two are free to download. But Yegi's a great place to go if you can't find it in these other two. The other option is to make your own. And there's a lot of software out there you can use to make 3D objects to print. This webpage lists a bunch of them. My favorite, though, is OpenSCAD. And I actually did a YouTube video. You can go here and take a look at it, which gives a fairly comprehensive introduction to using OpenSCAD to model 3D parts for fun, for profit, for research, right? So I recommend you take a look at that if you're interested in learning about making your own parts. OpenSCAD is free open source software. There's another free open source product called Blender that's more for artistic as opposed to making mechanical parts or lab parts or whatever. So if you want to do more artistic stuff, Blender is a great thing to use. And then once you have your STL file, make sure it's printable, and we'll talk more about that. What kinds of things can realistically be printed? So we'll talk more about that later. Actually, we'll talk more about that now. Okay, so when you're 3D printing something, note that you cannot print on air. This is a thing from Thingiverse that someone made to kind of test how well your printer can print at different angles. So what if I wanted to print this thing right here? It's not going to work, right? Because as I print starting at the bottom and go up, when I get to this point right here, I'm printing on top of air. Air will not hold this part up. So sometimes the solution is to rotate the part. If I rotate it this way and print it this way, now I'm not printing on air, but I do have these long overhangs. And the printer can print off to the side horizontally for kind of short distances. This is a really long distance. It's going to try and print. It's going to sag. This is not going to work. But if I lay the same part down like this, there are no problems. I'm not trying to print on air. I don't have big overhangs. So figure out which way to put the device which way to print it out relative to the print bed, and that can solve some problems. Now, if you can't solve the problems that way, another solution is to use supports. You can tell the slicer, hey, I'm going to print this, but I know there are problems, so generate supports. And supports are like little bits of plastic that are loosely attached that you can break off when you're done. I hate them because they waste filament, they take longer, but more importantly, they're a real pain to break off. Sometimes they don't break off cleanly and you end up breaking your part. Also, they leave jagged parts where they attached. So I try really hard to avoid supports if I can, but that is an option. Another option that's better than supports, I think, is to print in pieces. So for example, imagine I wanted to print a sphere. How am I going to make that stick to the bed, right? There's just like one point at the very bottom that it's got to stick to. That's not going to work. Well, you could use supports to hold it up, but that's a bad solution, I think. A better solution would be cut it in half, print 2 hemispheres. And even better than that, let's put holes in the hemispheres that we can stick a peg in to help us align them. So then we can like stick this peg in the holes, squish them together, and put some glue in there, and the peg will make sure it aligns right, and the glue will hold it all together. The super glue is a great thing to glue the plastics we typically use for FDM printing. So just super glue, the gel stuff I think is best. Notice this little peg I made to go in the holes. It's octagonal. It's got sharp edges. I found one trick to make sure things fit really tight is to make the peg just like maybe 0.5 millimeter bigger in diameter than the holes, but make it octagonal so that the parts that are a little too big are just points that can easily be compressed. The plastic can be squished. That way you can make a really tight connection so the parts will align really well, and maybe it'll be tight enough you don't even need glue to hold it together. All right. Here's some other design principles. Remember, it's drawing with the nozzle. So the nozzle that's installed on our printer is a 0.4 millimeter nozzle. I have smaller ones we could try, but kind of 0.4 millimeters is standard. And so it's like you're drawing with a marker. You can make the layers fairly small, down to about 0.1 millimeters, but you're always drawing a line which is 0.4 millimeters wide, which means you're not going to make things narrower than 0.4 millimeters. And you're not going to make something which is slightly bigger than 0.4 millimeters, right? So I can make a line that's 0.4, or I can put 2 lines, and that will be 0.8. Bigger than 0.8 I can do very precisely, right? Because I can leave a gap between the lines that's very small. And so the resolution of the printer in the XY plane is smaller than 0.4, but remember it's like drawing with a thick marker. You can draw very precisely with a thick marker, but you have to remember each stripe is 0.4 millimeters wide. All right, step 3 is choosing a material. It will probably be PLA. PLA is the most common 3D printer materials. If it's not PLA, it will probably be something called PETG. And I'll talk about these materials for a minute. But just note, if you are not going to print with PLA, you need to talk to me first, because bad things can happen to the printer and printing can go bad if you're using different materials. So you'll need to talk with me before you do that. And even if you're using PLA, make sure it's a PLA that I have pre-approved. Okay, we'll talk more about that later. But what is PLA? PLA is short for polylactic acid, and it's just a type of plastic. It's cheap, it prints well, it melts at a fairly low temperature, so the printer doesn't have to get very hot, which means, of course, it's not very good if the part needs to get to high temperatures after it's printed. It is renewable, it's plant-based, and it's sort of biodegradable. Over time, it will, if left out in the sun and the weather, it will break down, but not really fast. So like parts that are going to be indoors, they should be fine for years and years. I've been printing for several years, and I've never had a part degrade. Even some that I've left outside have been okay. But over time, they will biodegrade, but of course, all the dyes and things in them aren't nice for nature. So they're, don't print wildly and think and forget about the environment. But they do have those advantages. The second most common material is what we call PETG, or polyethylene whatever that says. It's basically the same material that most like disposable water and soda bottles are made of, but modified a little bit with this glycol to make it the 3D print better. It's stronger than PLA. It's less ultraviolet and environment sensitive. So if you're going to print something to go outside in the environment, PLA is probably not great. PETG would be better. It's not much harder to print, and it's only a little bit more expensive, but there are some issues. You get more stringing, bed adhesion can be too good sometimes. You can destroy the bed if you're not printing correctly. You have to print at a slightly higher temperature, and it's not renewable or biodegradable. Also, you probably need to adjust your first layer height to make it work. So anyway, before you print with PETG, talk to me first. Before you buy any PETG filament, talk to me first. ABS used to be popular before PETG came around. It's kind of got some of the same advantages, except it shrinks when it cools, and so you get warping and things. So ABS is not used a lot anymore these days. TPE and TPU are kind of fun because they're flexible, like, kind of rubbery, like you could make a phone case with it. I've never printed with it because it's more expensive. So yeah, I don't know. And then HIPS and PVA is dissolvable in water. Some people will use this to make supports you can dissolve, but our printer only has one print head, so that's not an option anyway. And I've heard it doesn't work as great as you would think. And then there's a bunch of other ones, ASA nylon, polycarbonate, polypropylene, that have different properties. Once again, I have not printed with any of these, and so talk with me before you do anything. There's also what they call silk PLA, where they add some stuff to make the things come out shiny. So like things can kind of almost look metallic. And I have not had problems with silk PLA, so feel free to print with silk PLA just like you would regular PLA, as long as it's a brand I've approved. There's also infused fibers that have like carbon for strength or wood or metal to make things look differently. I have not printed with those. Better talk with me before you try any of those on our printer. Now, there is PLA for you to use. If you're doing just small prints, there should be some PLA next to the printer. If there's not any by the printer, if there's less than one complete spare roll, let me know so we can get more. But if you need a special color, special type, or if you're planning to print large things or a lot of things, you will need to bring your own filament, and you'll need to talk to me first. Make sure I approve the filament before you buy it. Also, keep your filament clean and dry. In Utah here, the filament doesn't get damp real quick, but over, a year or so, it will absorb some moisture if it's not stored properly. I have some dryers that heat the filament up that we can put the filament in if your filament is getting moist. If it's getting brittle or stringing too much, it might be that it's absorbed moisture. Talk to me and we can cook your filament and make it better, or cook our filament and make it better. Now, so if you're going to go off of the approved PLA list, you need to talk with me before you buy the filament. Pre-approved PLA filament. If you're just going to print with PLA and you want to just go and buy filament to print a bunch of stuff, these are the brands that I've printed with and I feel good about. I've printed with some other brands I was not as happy with. I've had some students use off brands that did nasty things to the printer. So these are the PLA brands that I am happy with. Prusa is the best. It's a little more expensive. You can buy it. Prusa is made in the Czech Republic, and so the shipping can be nasty if you buy it straight from Prusa, but they now have an American distributor, printedsolid.com, you can buy without paying the big shipping charges. Printed Solid has their own brand they call Jessie, which is also pretty darn good and a little less expensive, so you can get those both from printedsolid.com. I've had good luck with a brand called Filicube. It's made in America and relatively inexpensive. And then Hatchbach is a Chinese brand, but it's fairly good and inexpensive. You can get that off of Amazon. There's a lot of cheaper ones, but once again, I have not had good success. And in cases, they've actually messed up the printer. So these are the ones that are pre-approved. If you want to buy some filament and print things, buy one of these. If you want to do something other than PLA or a different brand, talk to me first. And both the regular PLA in the different colors and the silk PLA are just fine. All right, step 4, once you've got your 3D 3D object, you've got a STL file of the object you want to print, and you've picked your filament. Next, you need to generate the G code for the printer, and this is known as slicing. And you, guess what? Use a slicer to do your slicing. I really like Prusa Slicer. It is made by Prusa. It's a company that makes printers, and even though our printer is not a Prusa printer, I have a Prusa printer at home, love it, by the way, but the one we have here for you to use is a Creality printer. It's a cheaper printer, but Prusa Slicer works great for it. You just need to make sure you load the profiles for Creality, and that's the one I always use. Creality has its own slicer. It does not have a lot of options. It's kind of terrible. There's another one people use a lot called Cura if you want to look in that, but I highly recommend using Prusa Slicer, and this tutorial will assume you're using Prusa Slicer. So once you've got Prusa Slicer downloaded and installed, you pull it up, and it'll look something like this. To slice your object and get it ready to 3D print, there's a few things you need to do. First of all, you need to set that you have the correct printer settings. And so you need to set it to Creality Ender 3. Now, if that doesn't show up as an option for a printer, you need to click on Configuration, then click on Configuration Wizard, and it'll come up, and you need to say, I want to install configurations for other vendors, and then click on Creality. And then if it gives you more options, you need to specifically install, other vendors, Creality, and then click Finish. If it asks for specifics, you want the Ender 3 Pro, or Ender 3 if that's all they have, configuration files. Okay, and then once you've got those installed, you'll go up and select Creality Ender 3 or Ender 3 Pro here in the printer. The filament, probably just generic PLA, unless you're using one that there's an actual specific configuration file for. Okay, and then you need to load your file. So click on Import and import STL, and you can open up your STL file. It'll open up, a file opening dialog, and you find your STL file and you open it up, and it'll show your object right there. Now you can place multiple objects in the print bed. So you can import it, you can import something else, you can print a bunch of things at once as long as they all fit on the print bed. You can even click on an object and do Control-C, Control-V if you want to, and paste a copy of it if you want to print multiple copies of something at once. All right, so once you've got your object there, make sure you choose the correct printer, make sure you choose generic PLA unless you're using something else. And then here's the print setting. Normally you will set this to 0.2 millimeters, but if you need really high precision, you can change it to 0.1 millimeters. It'll take twice as long to print when you do that. It won't use more material, significantly more anyway, or maybe even less, I don't know. It'll be about the same amount of material, but your layers will be smaller so you get more precision if you need something that's really precise. So 0.2 millimeters normal is usually what you want, but you can do smaller if you want high details. Now you can click on the part to move it around, and you can rotate your view and things to make sure everything looks good. All right. You can also come over here. If you click on a part, it'll turn green. That's the selected part. And you can change its position manually by typing in numbers. You can also rotate it. So you can rotate it, like I can rotate it. This is probably how I want to print it, right? Because there's no overhangs. This has overhangs and only one little line of contact with the print bed, so that's a recipe for disaster. But if you started off and your part was like this, you could rotate it so that it sticks better to the bed and doesn't have overhangs by using the rotate functions. All right. Infill, you need to set the infill value. So when you 3D print a part, it doesn't make solid plastic. It kind of does the outside walls plus an infill pattern to make it stronger. The more infill, the more plastic it's going to take, and the longer it's going to take to print. For most standard parts, 15 to 25% is plenty. Go to 50 to 90% if it has to be really strong. You don't want to do 100% because you need some gaps there so that your walls can be at the right place, right? Because we're printing with a thick marker. All right, and then there's this option for a brim. Usually you don't want that. But what a brim does, well, okay, I guess I'm coming back to brim. Now, if you click on print settings, there are more things you can adjust. If you go from the simple to the advanced to the expert level, you get even more options. So here, let's, anyway, then when you're ready to slice, I guess we're going to go more into the advanced stuff in a minute. But once you've got everything right and everything's set up right, you click on Slice Now, and it will generate that G code. And then, whoops, you can export the code. Oh, here we go. Here are more settings. Oh yeah, sorry, once you've sliced, there's a little bar over here that you can grab and you can move up and down to kind of see into the slice. And you can see how it's going to generate the different layers if you want to, if you're curious, if you want to see if everything's okay. All right. Supports. So imagine you have a part, you know, this is a terrible way to print this part. I'd do much better laying it down like we did before. But imagine you have a part that it's just got overhangs and problems. You can enable supports to deal with that. So if I click on supports everywhere, first thing it says is, oh, this will work better if I enable this thing. So just click yes, and it'll enable some option. And see, it makes these supports. And they're ugly and they're painful. Like I say, I avoid supports when I can, but if you need them, that's how you enable them. All right, now, after you slice, it'll show you, you know, how it's going to be printed. This line right here is just a line that it draws to make sure, just an outline, just to make sure that the plastic is flowing correctly and everything before it starts printing. It's a waste of plastic, and it can be really hard to get off of the print bed when you're done. So I like to turn it off. It's called a skirt. And the way you turn off skirt is you enable advanced settings, go to print settings, click on skirt and brim, and set the number of loops to 0. That'll get rid of the skirt. I recommend doing that because they're just a pain. All right. So click on advanced, click on print settings, go to skirt and brim, set the loops to 0 if you want to get rid of the skirt. A brim, here we are, the brim. If you check this, it'll print one layer of stuff outside of your object. That's useful if your object does not have a very big profile on the base and you're worried it's not going to stick well to the base, right? Sometimes you'll start printing something, it'll come loose from the base, it'll fall off, and the printer will keep going, but there's nothing for it to print on, and it just makes spaghetti. I think I have a picture of spaghetti later. So if you need more surface on the bottom, you can do brim. It'll add extra layers, and then when you're done, you have to cut it off. All right? So only enable brim if you need it, because it's a pain. You got to cut it off. But if you do need the brim, that's a way to help it adhere to the surface better. All right? So then once you've got everything the way you want it, click on Export G-Code, and you'll bring up a file dialog, and you can then save the G-code, which is what you're going to give the printer to print the part. Okay, Splishless Slicer has many more features. I'm glad to help anyone with questions. Things like detect thin walls, ironing helps make the top layers flatter. You can have variable layer thickness, like if you want part of it to print fast, but then other places you need more precision. Complete individual objects is nice, where you can actually go and print a whole object, then move over and print another. So if the printer crashes, you don't lose everything. There's different infill types. Vase mode is great, where it just does like a single outline. It's really fast, and you can print thin things when you need to. Okay, but you can ask me about those or look online if you need more help with that. So step 5 is you got your G-code, you need to put it on the micro SD card. So if you look at the printer right here, here's a zoom in, here is the SD card. You push it in and it pops out. Be careful because it's spring-loaded. It'll jump onto the floor and it's tiny and you may lose it. All right, so push it in, it'll pop out, then you take that and you either stick that into your computer if your computer has a micro SD card slot, or there is an adapter that should be by the printer that you can stick it into that and plug it into your USB port on your computer, and then you're just going to move the G-code file onto that. Then put it back into the printer. Note that it goes in upside down with the electrical contacts on top. Okay, then once you've got it in there, you're going to turn the printer on and make sure that the bed is mounted correctly. This bed, this top part comes off. It helps you like remove the objects and then you stick it back down, and it's held in magnetically. But it's easy to put it on such that the edge rubs against the printer, and that's bad. So make sure you put it on and that you can move the bed back and forth and it doesn't bump up against anything. All right? The power switch is on the right next to where the power cord comes in. So you turn it on, put the bed on, and then you need to level the bed. If you've recently printed and everything went okay, you don't need to do bed leveling. But over time, the bed will shift. So if you haven't printed on it in a while, or if you've had problems with things not sticking well or not printing right, or if it's been a while, it's a good idea to level the bed. And the way you level the bed is first you come over to the controller, you push the big button. You push the big knob. Then you turn the big knob until Prepare is highlighted. Then you push the big knob to go into the Prepare screen. Okay? The Prepare screen looks like this, and you want to turn the knob until it gets to Auto Home. Then you push the knob, and the printer will home, and it looks something like this. So it goes over, there's some little micro switches that help it find the origin. And it will go to the origin. Okay? All right, and there it is. And once it's at the origin, the next thing you want to do is you need to disable the stepper motors, because with the stepper motors on, they hold everything rigid and things can't move. And so what you're going to do is you're going to push the button again, go to Prepare, push the button, and then in the Prepare menu, you're going to go to Disable Steppers and push the button. And that will turn off the steppers, and now things can move. Don't move it up and down, but move it side to side. So now you can move the print head side to side, and you can move the bed back and forth. And so what you're going to do, now that you got it homed and you can move it, is you're going to put a piece of paper between the bed and the nozzle. It can be hard to get the piece of paper in. I found if you move the nozzle all the way off to the side and kind of tuck it under and then move the nozzle in, that's easier to get there. So you're going to put this piece of paper under it. And the idea is there are these 4 leveling knobs, 2 on this side, 2 on the other, and you're going to put the printer nozzle right above one of those leveling screws with the paper under there, and you want to make sure that the paper can move but not easily. If the paper just moves in and out without friction, then the nozzle is too high. If the paper is just tight and doesn't want to move, maybe it tears, then the nozzle is too low. And so you need to adjust these knobs, or the knob underneath, until it grips, but it still moves. So it moves with friction. Once you have leveled this corner, you're going to go to the opposite corner, the far side. So you'll push the head over, pull the print bed out until you're over this knob over here. Now, once again, it's hard to get the paper underneath it, so you want to make sure the paper stays under it while you move it. So kind of move the paper with the print head. And again, make sure that the paper moves, but with friction. And adjust the knob underneath here until you get it just right. Then you're going to go to this knob over here and do the same thing. Adjust it until it grips nice, right? And you can reach behind there, adjust the knob, and then go to the front right corner and adjust that knob to get it right. Okay? If you've made any adjustments on one, there's some crosstalk and it will affect the others. So then you have to go back and do it again. So you're going to go back to the front left corner and check it, then go to the back right. Just do this pattern over and over again until you don't have to adjust anything, right? In all 4 corners, pinch the paper, let it move, but with friction. Okay? Then the bed is leveled. The next step is you need to make sure that the printer has filament loaded. Hopefully there's already filament loaded in it and you're ready to go and you can just start printing. But if there's no filament loaded, or if there's not enough filament and you're worried it's going to run out, or if it's the wrong color or something, you're going to need to load or change the filament. To load or unload the filament, the extruder must be hot. And before you get the extruder hot, you need to move it away from the bed. So let's talk about how to do that. So to move the extruder away from the print bed, you're going to push the button scroll down to the Prepare menu, push the button. In Prepare, you're going to click on Move Axis. And after you click on that, you'll get an option, to choose which axis to move. So click on Move Z, scroll down and click on 10 millimeters per step, and then turn the knob clockwise, maybe 3 steps to move it 30 millimeters, and it will move up until it's a little bit above the bed. Once the extruder is above the bed, then we can preheat. We can get the extruder hot so that we can load or unload the filament. So to do that, push the button, scroll again to the Prepare menu, push the button, and then scroll down to Preheat PLA and click on that. And when you do that, it'll give you 3 options. So one option is just preheat everything. Another is just preheat the extruder end, and one is just preheat the bed. So we only need the extruder head hot in order to load or unload the filament. But since we're probably going to print just as soon as we're done, it's not a bad idea to just preheat both of them. Just click Preheat PLA, and then the bed will be hot when we're ready to print. Okay? So go down to that and then click. And then notice when you go back to the main screen, up here, this is the extruder, or the hot end. It tells you the set point temperature and the actual temperature. Over here, that's the actual temperature. Over here is the set point for the bed, and here's the actual temperature. So wait until the hot end gets close to its set point temperature, and then you can remove or load filament. Okay? So if you look at the printer, the extruder motor is over here. Okay? And so if we zoom in on that, there's this assembly here. There's a little gear and a roller, and when this motor turns, it pushes the plastic filament into this tube, which is known as the Bowden tube, and then it gets pushed out the extruder. Okay? So if you need to pull filament out or put filament in, you're going to put your thumb right there, put your finger right there, and squeeze the two, and that will open up the gear and the little cylinder, the pulley. And then you can just grab the filament and pull it out. Okay? And then to put new filament in, you just push the filament in. It's kind of a pain because there's a little hole here, and you got to wiggle it around till it gets in the hole. And then it nicks down here with this connection. You got to wiggle it around until it goes in there. And then once you get it in the tube, push it as far as it'll go. Okay, and you'll see the filament go down the tube, and then until it goes all the way to the extruder. Then click on Prepare, go to Move Axis, and scroll down this time to Extruder, and move the extruder maybe 10 millimeters, right? And what that'll do is that'll push the filament through, and you should see a string of filament coming out of the hot nozzle. Since it moves at a centimeter, but the nozzle is smaller than the diameter of the filament, you should get more than a centimeter of stuff coming out the end. And once it's coming out and flowing well, then you've loaded your filament and you're ready to go. If you're changing colors, you want to do this until it's coming out the right color, that there's no more of the old color in the hot end. Okay? And we'll show this when we do the in-person training, which you must do after this before you're authorized to use the printer. I'll go show you how to do this more carefully. Now, if the filament runs out and there's nothing to pull on, this little quick disconnect thing here, you can unscrew that and then pull the filament out from there. Or if you're loading filament and you just can't get it to go in there, you can unscrew this, get the filament in, then screw it back in, and then push the filament all the way. So this little brass part unscrews. Okay, now you got the printer ready. You just click Print. So you click on the menu, and instead of scrolling to Prepare, you scroll to Print from TF. TF is another name for a micro SD card. Click on that, scroll down to find your file, and click on it, and it'll start printing. You don't have to sit there and watch it. It'll usually take hours to do a reasonable size print. I usually will wait to see if the first layer prints okay, to make sure that things are adhering to the bed well before I go. And you don't have to sit and watch that, but I will maybe go do something for a few minutes and come back and make sure that the first layer has printed well. If it hasn't printed well, you need to click and go to Stop Print and stop the print, clean off the bed, get all the plastic off of it, and then probably you need to re-level the bed and try again. If it just isn't working, let me know and I will fix it. Do not try to fix the printer yourself. I've had bad experiences with people trying to fix the printer that didn't know what they were doing, and things got put together wrong, and it was a lot of work to figure out what the problem was and fix it. And so yeah, just let me know. I've done maintenance on these printers many times, so if something is not working right, ask me right away. All right? Then step up is to clean up and turn off. So you remove the object and the skirt or any other plastic that's been put on the bed. Remember, the top of the bed comes off. It's magnetic, and you can flex it to help you get things off. But once you have everything off, replace the bed correctly so it doesn't rub against the edge. Turn off the printer, and let me know if you had any problems, or if we're running low on filament, or if the print bed just looks awful and needs to be replaced. Let me know. Troubleshooting. In bold, the main thing is ask me for help. Don't try to screw and unscrew things, tweak things by yourself. You may be smart, but I have experience with these printers, and I have experience with other people trying to print them and making a lot of work for me. So ask for help. If it's something simple like how can I design my parts better so that they, adhere to the bed better, you can search the internet, but don't try to modify the printer. Talk to me. And over here on the right, this is what happens when your print falls over. It doesn't stick to the bed well. And the printer keeps trying to print, but there's nothing to print on, so it just makes spaghetti. Anyway, now after watching this video, you're ready for a short in-person training. So I will set up some times when people can do that. And once you've watched this video and done the in-person training, then you should be able to print stuff on your own. Thanks for watching.